Welcome to a new Teardown video. This time it's another Heathkit. It's been a long time ago since I got some Heathkit stuff. So this is a model IM-12 and it's a harmonic distortion meter. This looks like it has been a little bit modified. This is not the original button and this is not original either, so there's actually a new one. So I assume this pot is defect and they just drilled another hole and added a new one. I don't know anything about this one. I did play a little bit with the buttons and then I saw this. So when I'm turning this one is turning. So it looks a little bit like this is a readout. This is not a button you're supposed to turn. You're supposed to turn here. So this is the tuning and this is a readout. So there's some sort of a gearing between those two. I'd love to see what is going on here. That is interesting. Balance. And the ranges. Set level. Another frequency range. Another set level. That's a little bit interesting. And this will be the output for your scope if you want to see what this meter is showing. And this will be the sensitivity in volt and in percent. That is a little bit confusing. I must admit I didn't read the manuals. I didn't do a lot of research. What I'm doing is I try to power this up and see what happens and see if I can figure out how to operate stuff just from the front plate, because that is the most fun thing. So I think we should power it up and see if it blows the fuses. So first, let's just power it up and see what happens. Oops, I was an idiot. Let's try again. 0, that is a good sign. And 27, 21, 18 watts and 19 watts, 25 watts, 36 watts, 44 watts. Ooh, that is scary. 36 watts, and now down again. 32 watts, 29 watts. Okay, so it's, ooh, how was it? Yeah, okay, now it's warmed up and it's alive. I can hear some boo. Yeah, that is good. Level, okay, so this meter is interesting. There's definitely something with the, okay, it starts to get better. Let's just work this out a little bit. Anyway, it seems to be alive. This is a good sign. It should, yes, exactly what it should do. It should be affected by this. That is a good sign. I think I will put in a sine wave and a scope, and we'll see what. It shouldn't react to that. Set level, and of course I will exercise a little bit on the switches and see if we can get. Seems to be all right. Not too bad, and it's stable at 26 watts. So nothing is going to blow up any minute. Yeah. See, it's a little bit unstable. Ooh. Let's just play a little bit with this. So I put a scope on the output, 1 kilohertz, 100 millivolts peak on the input. Let's try and play a little bit. So it seems like this is alive. And this is 1% sensitivity. Ah, okay. So this is the highest sensitivity. Right, so this is tuning. Ah, we should do, yeah, okay, see? Frequency range is 200 to 2K. So that will be in the middle of that. So what we should dial here for is a 0. Ooh, look at that. Now 0 is gone. See, that is a trick. And then balance. And then the signal goes up again. And down again, I guess. Oh, this needs a little bit more exercise. Because it's a little bit stable. Okay, this is jumping too much. It's just impossible to use. Set level. We need to have this for is where is set level? How do you use this? Now it's a problem that I didn't read the manual. So do I need to put this for 1% is full scale, right? I'm a little bit unsure if I put it for 0 here or for full. Ooh, that is scary. So this pot here is just really, really bad. That's definitely not going to make this easy. So if this is 1%, right? So I set the level for full and then I go back. So if this is 1% for full range, then I have 0.1% of distortion. And I should have a 0.0 some stuff. So I don't know if this works or not, but let me go to my signal generator and change the frequency like 10 Hertz up, 20, 50. Okay, so I can go. So okay, this is 100 Hertz off. And then I get a little bit. So the filters in this one is really not sharp in any way. Oy, oy, oy. Let me see. So that is all the way down. Here is 1 kilohertz. And now that was 110. Really? 1200. I'm saying this, the filters in this one is just so embarrassing. All right, whatever. This. Okay, I am not impressed at all with the selectivity or anything. But anyway, it's a fun instrument. And let's look what is inside the box. It seems like it's working. Just a very fast rear view. This one needs a little bit of service. The wire itself is like almost correct, but the screws look like they're original. So let's crack this open. And we're in. That was quite easy to take out the a little bit flimsy-jimsy case here. This is a classical Heathkit design. The cases and the front plates and all the metal pieces. It's just as thin as possible. And of course there are a few advantages of really thin materials. It's lightweight. And a lot of other instruments this age was really heavy and annoying because of the weight. And so Heathkit doesn't really suffer from the heavy weight. But I don't know if you can see this. It is flimsy, and of course the entire mechanical construction is like really. I don't know what you say about this, but of course all the good and important stuff is hidden in here, where it's a lot thicker, and so what? It's really not that important that all this stuff is a little bit, you know, bendy. And when I got this, all the connectors here was of course bent, and this is how they all look, because they are located at the very edge, so you will bump into them. They could have mounted them a little bit more in, and they will be much less damaged. And again, this unit reveals it was serviced, because those two components are not original. Two capacitors, they were changed. This is, however, the original 2-in-1 capacitor. This is a classical failing component. So this one you should change. And also look at the distance to chassis here. This should be improved a little bit. I guess I don't know about this particular module, but a lot of Heathkit products, they were also sold as kits. So I don't know if this one was a kit or if it was a purchased already assembled kind of unit. It looks quite alright the way that this is assembled. It doesn't look like it's too much first timer over this. I would have bent those parts with high voltage away from metal. I also see this is the 110 volt winding, and that will be the 220 volts. So could have been cool with a little note in here with the wire colors and stuff, because if you want to change this in the future, it would be a lot easier. That is what I like to see. And that will be the tuning done by a wire on a very bendy front plate, but see, it's quite flexible, so that will work absolutely fine. And the resistor that goes through here is also pretty cool. I kind of like that. That is of course going to work fine. The mains transformator is not that big and heavy and nasty, and oh yeah, this means new tubes in 95. So the previous owner was nice to write down when this baby got new tubes, so that's pretty cool. But it can't be all the tubes, because look at this one. It says, let's get some light, Heathkit on it. Look at that. So this gotta be the original. Ooh, that socket is almost without this tension. Then this is the voltage regulator tube, also the original one. Let's see if this one. Yes, that is definitely a new one. Oh yeah, you see? And those are the values. Yes, of course it is. That will be the two values of the two triodes in this one. And that is really nice. I love it when he writes this down, because this is the values. I gotta know the guy that gave me this one. Got a tube tester, you know? It's really cool with the tube tester dudes. Ooh, what is that? A Teardown tube. So this is from something else. Wow, that is sexy. And what have we got here? Another ECC83, and also, ooh, perfect identical values. I love it. So that is going to work as well. And what have we got here? Sylvania. This is probably also a new one. I'm not so good with those US numbers. I'm sorry about that. That is probably also fine, because the unit kind of work. How is that done? Ah, come on, man. My patience is not what it is used to be. Never was any good, by the way. This one is good. Yeah, I need to go through those pots because they are not really good, and especially those two. And that was the mod I really would like to see. So what is the trick? So there's a new pot, and that is a lot worse than the original one. And why is that? That I need to figure out. Why is that? What is the trick? That looks a little bit weird. So it is, the input is here, still goes through that one, and then what the end point of this pot goes to that pot. What? What is the idea? Please enlighten me, God. That I don't understand. This is ground of the input. Most likely this wire is going to a ground point. No, it is not as well, but it gotta be an input ground point of some sort. But I want to go and clean up a lot here and see to everything is going to work. I just wanted to show you guys what this baby consists of. I think we'll omit this added pot and get back to the original one, because I actually think the original one works a lot better. This I need to move. Don't touch anything here, because if there are no bleeder resistors, you could still get electrocuted. Some half an hour ago, since I powered this up, I guess. But other than that, beautiful, beautiful unit. No PCBs, no funky stuff, just flying components and what have you. So there's a shielded cable from the sensitivity button and switches with all the fancy pantsy components. Yeah. Well, it's pretty cool. I want to see in here, but I think we're gonna find a big variable capacitor. Who wanna bet? So of course the variable capacitor is down here, right? And here is the different frequency ranges switch. But now look carefully on the switch. This was supposed to be absolutely shiny. I don't know how I can show you guys how dirty this is, but it is all sorts of colors of dirty. It's only a little bit of shiny where I've been moving it. I'm just, pushing the corrosion a little bit, or the dirt, or whatever you call this. So that's definitely an easy fix here, just to clean up the switches as always. So that is the one of the switches I want to clean up. And again here, yep, same problem. It is dark as black. Look at that. That switch, oh, you can see it. See the moving parts here. Oh my gosh, this is dirty. I'm gonna try my secret tricks on the switches, and we're gonna see if there's magic. And this one is of course accessible from the outside. This is the classic balance filament AC midpoint, and yeah, this is of course, when you balance the midpoint, you will move the AC point to the left and to the right of all the tubes, and this way you will minimize hum. So, of course, you need to have this on the outside, and this pot is almost in the middle. I was so close to say exactly, but of course this should be in the middle. Is this damage? Yes, it is damage to this resistor. And 1% resistors, pretty good. This one is a new age component as well. This is not old tech. So somebody changed some of those resistors, right? Those can't be that old. So this was the lid around the trimmer capacitors, and look what I just did. This is my finger. I don't know if you can see this, but it's full of metal dust. This is just full of metal particles, and this is one of the reasons why self-tapping screws is just the worst idea ever. Look down here, how full of metal dust it is. So every time you screw a self-tapping screw in here, you will release all sorts of particles from the screw and from the thread, and it just drops down and create a little puddle of metal dust, and this will go sooner or later into something where it's not supposed to go. And this is one of the reasons why I am not particularly in love with Heathkit. They just did everything wrong. I'm just saying, you know, flimsy metals and everything is just, look at that, it's just what can you say? So this is how you change the bulb. You just push it back. It was sitting here in this rubber, and I didn't see this work at all, and it's covered with this black thing. But why is it really that? Because this is completely tight all the way around, right? And there's a little red piece of tape here. So this is interesting. So what I did is I took a flashlight. Come on, man. Like this. And shined a bright light on the red dot. And yeah, there's a little red dot here on the top. This is supposed to be the on indicator around here, up there. Okay, so it could have been made to illuminate the entire screen or something, but no, it's just a little funny red dot on the top. Cool. So I better see the specifications for this bulb. And with a little bit of exercise, the bulb is now working. Great. So got this pretty cool indicator if you know where to look. But if you turn on a lot of light like this, there's no way you can see this is on. Really? I can't see it, and you sure can't see it on the video. Well, you can hear it's humming, so so I think that is the best indication it's alive. Alright, I need to remove or disconnect this as at least, right? I got good news. After all this cleaning, it's actually working. It's a lot more promising. And I also learned a lot more about how it's actually working. So, in the first 4 settings of sensitivity, you got a voltmeter. In those settings, of course, your level knob is not affecting the readout. So if you put this in 1 volt RMS full scale, and I actually did input 1 volt RMS 1 kilohertz sine wave at the moment. So this voltmeter works. Okay, so I put it in 100% sensitivity, set level. So now I need to adjust the level for 100%. Okay, so that is my 100%. Now the level is calibrated and I can go into the frequency setting. Since I'm running at 1 kilohertz, of course I need to dial in the tuning until I have a dip. So now I found the right frequency, and this one reads out 100 in this range, so that will be 1 kilohertz. Okay, let's see. A nice dip here. Okay, so let's go down 30%, 10, 3. Okay, so in 3%, I can fine tune again. Ooh, of course now it gets a lot more critical. And I need to be super accurate. Get it as low as I possibly can. Like here, right? There's a little bit of a springy feeling on the strings or on the wire. So that is probably not the best solution for so sensitive adjustments. But now that is good. And then the balance is again a way to get as low as you can. So now go to 1% for full scale. See, that is 0.1 and 0.05% is what we have here. And that is actually the number of my input signal. So it's actually reading 0.05% of distortion. So that is actually working. That's pretty good. And I didn't change anything. I only cleaned up all the switches and pots. That is what I did. Magic, magic. All right, so it was that easy, and now I can assemble this and be happy again. And good night.